Okay, here's my video guide for lesson 6.1.2, talking about conditions we can use for triangle congruence. Now, we've done conditions before in chapter 3, and we did the conditions for triangle similarity. And if you remember, we had side similarity, side angle similarity, and angle similarity. Today, we're going to investigate what other ones could we have for triangle congruence. Are they different from the ones we saw for similarity? Are they the same? Are there some that's the same, some that's different, and how many total do we have? Okay, so we're going to go through it, and we're going to try to figure out which ones we have. So here, we're going to start by, again, Derek wants to find general conditions that help us determine if triangles are congruent. To help, he draws the situation to the right, what we see right here. And it says if two triangles have this relationship shown to the right, how do we know they are congruent? So the two things, and this goes back to the lesson 6.1.1, and it goes back to chapter 3. We know that two triangles are congruent if they are similar and have at least one pair of congruent sides. And so we're taking a look at this relationship we see to the right. Well, are they similar? Are these triangles similar? And do they have at least one pair of congruent sides? Well, I see that they have side, angle, side, and side, angle, side. Side, angle, side is one of my similarities. Again, my similarities are side, angle, side similarity, side, similarity. Oops, sorry. Similarity and angle similarity. This one has side, angle, side, so it's a yes to them being similar. I also have at least one pair of congruent sides, like CA and FD. So these triangles, yes, are congruent, and I know they are because they are similar and have one pair of congruent sides. I'm just not going to write that for time reasons. It tells us next to write a theorem in the form of a conditional statement saying if two triangles blank, then the triangles are congruent. The answer I'm looking for here was like if two triangles have two pairs of congruent sides with a congruent angle between them, then they are congruent, or then the triangles are congruent. Okay, and we call that side, angle, side congruency. And usually we use our congruency symbol. I don't have that on my keyboard, so I'm saying side, angle, side congruency. And that's one of 5 congruency conditions. So that's the first of 5 congruency conditions that we're going to learn in this lesson. Okay, on to slide 3. This is where we're going, or tasked with, finding the other 4 triangle congruent shortcuts. And so what we're going to do is we're going to evaluate each of these, A, B, C, and D, E, F, and we're going to say which ones of these give us congruency. So what I'm looking for here is side, side, side. Do they meet those 2 conditions here? Are they similar, and do they have at least one pair of congruent sides? So let's do one together. We see that they have similarity because ABC and ABC, that's side, side, side similarity. And they have at least one pair of congruent sides because A equals A. And so, yes, there is congruency, or yes, this is a congruency condition because it has similarity and at least one pair of sides that is equal. All right, I want you to explain a little bit further in yours, but then we can add it to our list. Side, side, side similarity, or sorry, congruency is one of ours. So now we have 2, there's 3 left, okay? The other one is hypotenuse leg is going to be a yes, and I want to explain that one because that one can throw people off. But hypotenuse leg is a yes because of the Pythagorean theorem, okay? And so if we look at these 2 triangles and we look at the Pythagorean theorem 2 times, a squared plus b squared equals c squared. For the first triangle on the left, and then we'll do another Pythagorean theorem for the triangle on the right. A squared plus b squared equals c squared. Okay, well, if the hypotenuse and the leg are the same in both triangles, that means if I call the leg A, one of the legs is A, if I call that, I can delete it here, 4, and I call the hypotenuse, my c value, 7, what that means is, in the other triangle, that leg is also, if I can again click it, that leg is also 4 and the hypotenuse is also 7. And you can see that if I solve this Pythagorean theorem for B, I'm going to get the same answer, which tells me this third side, this missing side that I don't have, is going to be equal as well. And so there is side, side, side similarity, and then we have at least one side that is congruent, like L is congruent to L. And so hypotenuse leg does work, and hypotenuse leg will only work in the case of a 90-degree triangle or a right triangle because of the Pythagorean theorem. Okay, so this one would be yes, and I'm going to have you find two others now. Because we have side, side, side as a yes, we have hypotenuse leg as a yes, and we have side angle side as a yes, and you need to find from C, D, E, and F which other ones are yes. Okay, again, there's a total of 5. In 6 and 7, excuse me, in 6 and 7, you're going to apply your 5 conditions to answer these questions A, B, C, and D, E, F on the next slide. You can see in A, you could say, yes, these triangles are congruent because they have side, angle, side congruency, and that's all you have to write. Yes, these triangles are congruent because they have side, angle, side congruency. Then you're going to try to do the same thing on B and on C. If it's a no at any point, just say, no, they are not congruent because they do not have the triangle congruence condition. Okay, 7 is a little more difficult. We have problems like D and E where we actually have to use angle relationships to help us solve. And so the thing to look out for in D is that we have this vertical angle relationship here happening. Anytime two lines intersect, we get vertical angles. So we have an equal angle here and an equal angle here. Also, we have these parallel lines here getting cut by transversals, which gives me an alternate interior relationship. So I also have an angle here on the left and an angle here on the right from alternate interior that are congruent. And so I actually have angle, angle, side, and after you complete slide 5, you'll see that angle, angle, side is one that works for us. Okay, so this one for D is actually going to be yes congruent. And E, you're also going to have to use an alternate interior relationship to solve it. Another thing to note with E and F is that what I see here is called a shared side. If at any point your triangles have a shared side, we're allowed to say that those sides are congruent. So really you have an angle, a congruent side. If you can show another angle is congruent in these two triangles, then you should be good to say that they are congruent. Same kind of thing for F. Knowing that you have a shared side here that's congruent, you should be able to draw a conclusion. All right, that's the last slide. If you have any questions while you work on it, please reach out and ask me.